Hello everybody, welcome back. In this lesson we're studying optics. Optics is the study of how light behaves and how we can control and figure out where it's going to go. Anytime light strikes a surface and reflects off, we call that surface a mirror. So in this slide, I'm showing a mirror laying on the ground, and our light source is going to be that yellow star that's kind of in the upper left-hand corner. Now that light source, that star, has light that's being emitted in all different directions, 360 degrees all the way around. But we're not going to deal with most of it. We're going to imagine just a single beam of light, just a single ray, in which all the photons are traveling in the same direction, from that star straight down to our mirror. So that light ray, which I've made indigo in color here, is called an incident light ray. Incident because it's incoming to the mirror. When that incident light ray strikes the mirror, if we want to describe what direction it came from, we need something to compare to. So when we measure an angle. And what we always will compare to is an imaginary line that's perpendicular to the surface, and that's called the normal. You probably remember we've dealt with normals before, back when you were learning about friction. You learned that the normal force was always perpendicular to the surface. Well, the normal is the line perpendicular to the surface. So when the incident light ray comes in and strikes the mirror, it then bounces off, and as it bounces and goes away from the mirror, we call that a reflected light ray. So I've made the reflected light ray here red to make it easier to remember. When we define and measure that angle then, the angle that the incident ray was traveling, we measure between the incident ray and the normal. This angle right here. That angle would be the angle of incidence. Now some people often wonder at this point, well, why didn't we just measure the angle between the incident ray and the mirror? That would work. And actually it would work. But you'll see later on when we work with a little bit more complicated mirrors, they're often curved. Sometimes the surfaces are irregular, and it makes it difficult to measure those angles. So it just makes life easier if we have a nice consistent reference point, and that's what a normal is. So the angle of incidence is measured from the incident ray to the normal. And the angle of reflection then would be the angle between the normal and the reflected light ray. And one of the first laws of optics, one of the most important ones, we can actually see shown in this image. And that is the angle of incidence is always equal to the angle of reflection. That turns out to be always true. Now, there's some kind of interesting things that happen because of that. Suppose that your eye was right up here in this direction, and you were looking right down that reflected light ray. When that light ray went into your eye and triggered your brain ever since infancy has been learning to figure out where things are. And it does that because it assumes that light rays always travel in a straight line. So when that light ray reaches your eye, your brain would assume, well, that light ray came somewhere from back along this line. And so when it sees the image, your brain will assume that that star that was creating the light is down here where we see the image. So that image is where the thing appears to be, and the actual thing may be somewhere else. Magicians make use of this all the time. They can use mirrors and various other ways to bend light as well to make us think that when we see something that it is where it actually is not. So the law of reflection is the angle of incidence equals the angle of reflection.